हेलो स्टूडेंट्स, गुड मॉर्निंग। वेलकम टू S2 क्लासेज। आज हम +2 क्लास का लेक्चर 9 शुरू कर रहे हैं। लेक्चर 8 हो चुके हैं। उनमें इस चैप्टर का सभी मटेरियल दे दिया है। फंक्शन, रिलेशन, टाइप्स ऑफ फंक्शन, टाइप्स ऑफ रिलेशन and exercise of Ncert. After that, miscellaneous exercise last. Here in this exercise, miscellaneous mixed questions are there, functions also, relations also. So some question relations, reflexive, symmetric and transitive. Then any function 1 and on to, then that function is called the bijective function. Okay, you know that I have given in the lecture 6, lecture 5, 4, 8 these all things. Okay, now this is same repetition of this full chapter, revision of this full chapter. Now how can prove this? So that the function f, question number 1, so that the function f such that real number 2 this set x belongs to R, x greater than -1 less than 1, and between 1 and -1 all real number is the second set, codomain set. This is codomain set and this first is the real number set, this is domain. So we have, so that for the defined by fx is equal to x upon 1 plus mod x. Question given, function given, x upon 1 plus mod x. X belongs to real number in the function. This function is 1, 1 and on to function. We have to prove it. Now in this, what proof for 1, 1, what we are doing? For 1, 1, what we are doing? Let two elements which are not equal in domain, so x1 less than x2, let for every x1 x2 belongs to its domain. Domain means real number. रियल नंबर में हमने क्या ले लिए? दो एलिमेंट ले लिए, कोई x1 x2. चूज एन एलिमेंट. ओके, एंड such that डिफरेंट एलिमेंट लिए, ऐसा कि फंक्शन जो है उसकी इमेज इक्वल है, यानी f ऑफ x1 इज इक्वल टू f ऑफ x2. दीज आर द इमेजेस. आउटपुट इक्वल एंड डिफरेंट एलिमेंट इनपुट, like this. Let, so after putting in the nature of the function these equal image and solve, then x1 equal to x2 is coming, then we can say it is 1, 1. Taken different and output same, but these are not different, these are equal. x1 equal to x2 has comes out, hence we can say it is 1, 1. This is the method, you know. Okay, now put here fx1 means in the function put x1, x value x1, so fx1 equal to x1 upon, so this implies x1 upon 1 plus mod x1 equal fx2. fx2 means putting x value x2 in the function, so then function will be x2 upon value of the function x2 upon 1 plus mod x2. Clear this? Okay, after this we have to solve modulus, x1 modulus. If both are positive, x1 and x2 both positive, then modulus positive. Okay, so cases we have to take. First case, if x1 comma x2 both are positive real number. Okay, belongs to positive real number. Okay, now positive real number, any real number is positive, so what will come? Positive upon 1 plus positive. Positive real number 1 plus positive real number, then it will come less than 1. Okay, positive, and this also same. So then we have to solve that this x1 any positive and 1 plus positive means positive x1 modulus of positive real number as it is positive real number is equal to x2 upon 1 plus any positive real number modulus is as it is positive real number. This implies cross multiply x1 plus x1 into x2, simplify by cross multiply, then x2 plus x1 x2 equal x1 x2 same will come there minus, so this implies x1 equal to x1. In this case it is 1 1, clear. Now second case, if one is negative other is positive, one negative then will come positive, multiply by, if x1 negative then modulus of negative positive, but up negative, so this will come negative number, then okay, then cross multiply, same will come result, okay, will come equal. After that, if both are negative, so this negative, then okay, negative modulus will be positive, negative modulus positive, and then this negative and negative, so both are negative number, then okay, then we can do that, will come same. So for every case it will be, so x1 upon 1 plus x1 will be equal to x2 upon 1 plus x2. In every case positive x2, x1, x2 modulus will be same, that if negative then positive, so up negative, here up negative will come, okay, clear. Now this will come from this, every case x1 is equal to x2. For every case, for every means you have to say for every x1 comma x2 belongs to a real number, this will come. So it is 1 1, so it is 1 1. Now after that, on to for on to take function y is equal to fx and find the range. Take function y is equal to fx is equal to x upon 1 plus mod x. Now we have to see here x belongs to real number, so if we are going to calculate the y value range, what will come? Yes, now forward this y equal to x upon 1 plus mod x. Mod x always will be greater than equal to 0 for every x belongs to real number. If real number negative inside, then again modulus will be positive. Okay, so it will be greater than equal to 0. So always this will be greater than equal to 0 means positive, means 1 plus something will be greater than 1. Greater than 1. So up may be negative or may be positive. If x value negative, so here negative upon positive. Negative upon positive. And positive will be like that. If negative 1, so positive will be 2. So minus 1 upon 2. So it will be always less than, we have to say this greater than 0 positive. So if we are adding here 1 plus modulus x, this will be 1 plus modulus x. This will be greater than 0 always or greater than 1. Greater than 1. Because 1 plus something. Okay? 1 plus something. If x is 0, so 0 upon 1 plus 0, then it is 0. So y will be 0. Okay? If 0, then greater than 1. For every this, x is 0, so then it will be equal to 0. So but if this will be 0, then it will be equal to 1. Okay? Is equal to 1 for every x belongs to real number. Okay? Think this. After that you will see it is denominator here. So then denominator is greater than and equal to 1. Denominator greater than and equal to 1. But numerator x, if positive x, if real number positive, then positive. If real number negative, then negative. Numerator negative. So means here it is clear that if we want to take here value of x upon 1 plus mod x, this value will be always greater than minus 1 and less than 1. It will be 0. For if x is 0, 0 upon 1 plus 0, that is 0. So y will be 0. This will be 0. 0 is in between. If negative and positive, then 0 to minus 1. If x is negative, y will come 0 to minus 1 between. And if x is positive real number, then this value x upon 1 plus mod x will be between 0 to 1. So now this is clear. So we can say y. So this is y. So y greater than minus 1 and less than 1. So we can say range set is equal to, so range is equal to range set will be equal to, this is our codomain also same, codomain set. Hence f is f is 1 1 and on 2 and on to function. So hence proved, which was there, we have to prove 1 1 and on to. Okay, now next question, Next question, question number 2. So that the function, question number 2, so that the function f such that real number to real number, f such that real number to real number and given by fx is equal to x cube, cubic function given by fx is equal to x cube is injective, is injective. Injective. Okay, injective means one function. We have to show it is injective. So proof of this, let x1 less than x2 for every x1 comma x2 belongs to domain set. Domain set is the real number set. So these are real number and the different both taken input, and such that image is equal, means f of x1 is equal to f of x2. So then this implies putting in the function fx is equal to x cube, then fx1 is equal to x1 cube is equal to fx2, put x value x2, then it will be x2 cube. Now simplify x1 cube minus x2 cube is equal to 0. Then two factors, a cube minus b cube factors, a cube minus b cube, a minus b, factors of a cube minus b cube. A minus b one factor, other factor a square plus b square plus ab plus ab. Okay, use this. Then x1, it will be x1 minus x2 one factor, other x1 square plus x2 square plus x1 x2. Okay, is equal to 0. Then this implies x1 minus x2 is equal to 0. Second factor, x1 square plus x2 square plus x1 x2 is equal to 0. Okay, now see here, x1 square, this factor you check, x1 if negative then positive square, negative then also positive square, x1 square positive, x1 2 square positive. If both are negative, x1 x2, so product will be positive, then it will not be 0. ठीक है, पॉजिटिव पॉजिटिव, इफ और नेगेटिव, इफ x1 x2 नेगेटिव रियल नंबर, तो इट इज़ नॉट पॉसिबल, सो ये रिजेक्ट हो जाएगा उसमें. नो पॉजिटिव चेक करो, पॉजिटिव, इफ बोथ आर पॉजिटिव देन पॉजिटिव, बट इफ वन नेगेटिव वन पॉजिटिव, नेगेटिव स्क्वायर पॉजिटिव एंड दिस पॉजिटिव, लेट अस सपोज वन नेगेटिव वन पॉजिटिव, x1 नेगेटिव x2 पॉजिटिव, देन इट विल बी नेगेटिव इंटू पॉजिटिव नेगेटिव. तो this is positive plus this positive square and product is negative, this also, so it is rejected. It is rejected, it is not applicable equal to 0 for every case, so rejected. This only from here, this x1 is equal to x2. Hence it is, hence f is 1 1 or injective. Injective function. Hence proved. Okay, now next question. Question number 3. We are doing that question easy, that question 2, 3, 4, 5. Now we are writing the find the number of all onto functions. Find the question 4. Find the question 4 number of all onto functions. Find the number of all onto functions. Find the number of all onto function defined on the set. Defined on the set 1, 2, 3, 4 up to n to itself. On set. On set 1, 2, 3, 4 and so on up to n. Natural number set. Okay, n element that. How many? N up to n. This finite set up to n, natural number. Okay, so then here to itself. On set this to itself. To itself. Itself means this set to the same this set. Okay, now this number of all onto function. Onto means second set, not left. Okay, onto. ठीक है, तो every element of the second set must have at least one pre-image, at least one pre-image. Any association of the every element of the codomain set must be with domain set element at least one. Okay, so it means no element left here, every element, and the range must be same. So we can say factorial and direct this. So we have to say कि number of number of onto function equal to means factorial n. Why? Because an element taken one time and again one less element taken, that also will be function. Again one less more element taken, that in this set. So then how many different onto function can be made? How much factorial n? N is the number of the element here, and factorial n means this always will be factorial n. Direct question, we have to write how many elements are there, that much will be the onto function. Okay. Now next question. Let A equal, question number 5. Let set A equal minus 1 0 1 2. This set A and B minus 4 minus 2. Minus 4 minus 2 0 0 and 2. This is B, set B. Set A and B like this. Okay. Find and G F such that FG such that A to B and FG two functions F comma G two functions from such that from A to B. Both functions from A to B. This question saying like this, R F and G equal, defined by fx is equal to x square minus x, defined by fx is equal to x square minus x, defined by this x belongs to A, x belongs to A, domain set A to B, domain set is A, x belongs to A. Fx defined this and gx and g function. How this g function? G such that A to B be defined by gx is equal to 2 and gx is equal to 2 into modulus x minus 1 upon 2 modulus. This g function defined by fx is gx is equal to 2 into modulus x minus 1 upon 2 and minus 1. This where x belongs to, for this x belongs to also A, and if both f and g domain A, output is B. This for both function, and function fx is this and gx is this. Then are A and B, asking are A equal B, question mark, this asking. Now solution, you find, put this in this G and F, find the output both output. Okay, both ordered pair must be the same. On A and B same set, these are defined, but you have to check if both are equal or not. Now for this, if f you are finding first f at x is equal to minus 1, x is equal to minus 1, then putting here in the function x minus 1, so f minus 1 is minus 1 square, minus 1 square is 1 minus, and x is minus 1, so minus minus plus 1, then is equal to 2. Now f of second element 0, if we are putting x is 0, putting x 0, so 0 square 0, 0 minus 0, 0. Then after that third element putting 1, putting x is equal to 1 in function, so 1 square 1 minus 1, then again 0. F putting third element 1, then fourth element 2, f2, then 2 putting 2 square 4, 4 minus 2 is 2. So these output here 2 0 2, so means output in the B only 0 comma 2, 0 comma 2, output these two. Okay, so it is not 1 1, it is many 1. Okay, now we have to check only these are equal or not. Now find the g function. G x is same belongs to A, means minus 1. G minus 1 if we are finding, then 2 into g. In the function g put x is equal to minus 1. So minus 1 minus half. Minus 1 and minus half, minus 3 by 2. And minus 1 outside. Then simplify, it will be 2, and then modulus का पॉजिटिव हो जाएगा, पॉजिटिव 3 by 2 and minus 1, 2 2 cancel, 3 minus 1 is equal to 2. This is 2. Then after that second element we are taking 0. If x is 0, then 2 modulus x is 0, 0 minus half, minus 1. Simplify, 2 into minus half modulus half minus 1. 2 cancel, 1 minus 1 equal to 0. Output 0. Output 2 and output 0. Next we are going to solve third element. Third element. Third element is in the set A, third element 1. Now G1, putting x is equal to 1 in the G function, 2 into 1 minus half. 1 minus half, half minus 1. Simplify, 2 into 1 upon 2 minus 1. Then it is also 0. Now after that, next element 2, x is 2, input 2, then 2 into 2, x की value 2, 2 minus half, 2 minus half, 1 and half, 3 by 2, modulus, minus 1, simplify, 2 into 3 by 2 minus 1, then 3 minus 1, then 2. So same here, we can say what order pair, same output. तो G हमारा G क्या बन गया, G function such that it is at minus 1 output 2, तो minus 1 associated to 2, and at 0 output 0, 0 associated to 0, and then after that third element 1, 1 associated to 0, and then 2 associated to 2. This is your G, and F your F such that F first element 2, okay, so minus 1 this, F minus 1 output 2, so first order pair minus 1 comma 2, and then at 0 it is 0, तो 0,0 and then at 1 x is 1, the output 0, 1,0, and if input 2 output 2, then 2,2. So these are two functions we have calculated according to the given nature and set A and set B. So we can say these both are equal because elements are the same. So we can say hence function f is equal to function g because both has the same element in its. Done. Okay, now I think over time we have to discuss forward. Okay, चैनल को वीडियो देखें, लाइक करें, शेयर करें एंड सब्सक्राइब द चैनल फॉर गेटिंग द नोटिफिकेशन ऑटोमेटिकली ऑन योर फ़ोन एंड मैक्सिमम स्टूडेंट्स को शेयर करें जिससे कि वो इसका लाभ उठाएं. थैंक यू.